So we deal. Yeah, I read it. I read it. Yeah, I read it. I don't have graph paper. Yeah. Right. So the scale of a graph. The scale of a graph is the value that each unit represents. Right. It determines how the graph is spread out. Right. Well, how the x and y axes of your graph are spread out. So the x and y axes of the graph are spread out. Are spread out. I see the person coming and then they'll. Yes, x and y axes is plural. Right. So what is your x-axis, right? Let's deal with the x-axis first. So you have, no, this is Amanda. That child didn't get you yet, nah? Right. So you have your x-axis is the horizontal line on a graph, right? So it basically runs from left to right, okay? From left to right, okay? That is what your horizontal axis is, right? It's your x-axis. What is this? Right, so y'all try to write same speed with me so I don't have to wait too long for you all, right? But I need you all to write. When we write, we internalize. Y-axis, right? So your y-axis is the vertical line, right? Is the vertical line on a graph. So some important things to note. The x and y axes meet at a point called the origin, right? They meet at a point called the origin. Right? This origin has the coordinates. All right, so let me put with coordinates the origin. Let's put it in brackets, yes? So the origin is actually 0 on your x and 0 on your y-axis, right? 0 on the x, 0 on the y. Okay? So every point on a graph is written as a coordinate. X-axis value is always first followed by your y-axis value, right? X-axis, comma, y-axis. So together, The x and y axis is actually called something, well, is called the Cartesian plane, right? So let's write that. So we have Cartesian plane So when you hear me throw around the word Cartesian plane, no, I'm just speaking about your x and y axis, right? So Cartesian plane, or it's also called the coordinate plane, right? Coordinate plane is a grid, is a grid formed by two number lines, right? These number lines will be your x axis and your y axis, right? Okay. So this is what we're going to investigate now. So we have a little background on graphs. Now I cannot go and do a set of little baby graphs at all because we are from 3 students and from 4 students. So the baby graph will quote unquote baby graph work when I get a list of points and you go on the x and y axis and you plot them and then you connect them and you see draw a shape or draw like an animal or some kind of thing. We don't have time for that, right? So we are jumping straight into CXC questions where we are dealing with functions, right? So I'm going to scroll along here. Everybody finish writing? Raise your hand if you are finished writing. Or if you need to write, raise your hand. We are jumping straight into CXC type questions where I give you a function. You have to establish the table, figure out how to label your axes, and draw these curves and straight lines, right? So the table below shows corresponding values of x and y. I just spoke about the x-axis and the y-axis. For the function, y is equal to 3 over x. Now, what I said here is x is not equal to 0, right? X is not equal to 0. So, y represents the velocity of a particle after x seconds, right? So they are just relating it to real life, right? Y represents the velocity of a particle after x seconds, right? So x would be the second. So this is 0.25 seconds, 0.5 seconds, right? 1 second, 2 seconds, 3 seconds going up the road. So we need to plug each one of these x values into my function to complete the table above, right? So this is how we complete our table above here, right? My x value for the first column was 0.25. When you put that into the equation, which is y is equal to 3x, right? This is, was that Amelia? Yeah? Say that again? So the Cartesian plane is what we call when the x and y axis come together now, right? So on the actual x and y axis on a graph paper is my Cartesian plane, okay? It's your coordinate plane, a Cartesian plane. We can now plot points and join points together, right? Everybody good there? Right, so I'm going to jump into my question now. So as I said before, the table below shows corresponding values of x and y. You all need to listen, eh? Listen. We have corresponding values to x and y on the table because once you understand the table, you would be able to understand the graph. Somebody mic on. Is Isaiah Alexander. All right. So I said that the function y is equal to 3x is what basically defines the graph, right? How this works is that for every value of x, I take every value of x, which is on the top row, plug it into the equation or function that represents the line, and solve. When you solve, you'll get the corresponding y values, right? So y represents the velocity of a particle after x seconds. So how fast a particle is going after x seconds, which in the first row is going to be 2.5 seconds. So I want you all to test the table, right? So go to your table. For this first column, x is going to be 0.25, right? So plug in, well, y is going to be equal to, I just wanted to put in a calculator, 3 divided by 0.25. And tell me if you're getting 12. 3 divided by 0.25, 12. Right, very good, Dominic. Right? So, what I want everybody to lock in here and ask me questions if all you don't understand. We going slow. The value, yes, go ahead, Joshua. Yeah, we do no hard work in today's. That's simple division or multiplication, right? 0.35? Wait, is that 0.35, bro? It's 0.25. Everybody getting 12? Right. So who can jump up and tell the class what we're doing for the second column? Let me see who can tell the class. Somebody tell the class what to do for that second column to find the y value. Go ahead, Aiden Ramjan. 3 divided by 2.5. Good try, but that's not it. Anybody else want to tell them what we're doing for the second column? Remember, we're in the second column. Right, somebody belt it out. 0.5. Ruja, next time let's see it. Because I see your hand on top first, right? So it's going to be Aiden. You see why Aiden Ramjan? Right, proper thing. So if I have to show working for these things, this is how the working is going to look, right? So I'm going to have, oh, right. So when x is equal to 0.5, right? This equation above here, or this function is what I'm working with for every single column here. So when x is equal to 0.5, y would be equal to 3 divided by 0.5. Y will be equal to what, my children? 6. I get 12, I get 6. Thank you. 6. Very good. Right? Let's go to the next one. We have another column where the value of y is missing. Let's find the value of y. So I'm just going to put a little partition here, right? When x is equal to, what is the value of x for that column where y is missing? The next column. What's the value of x? 3. Excellent, right? So you're using the same function above, which is y is equal to 3 divided by x. So this case would be 3 divided by, excellent. So y is equal to 1. I'm going to put that one here. You must draw this table, because this table is what we're going to use to draw the graph, right? So let's just do the last working, and I'll give you all a little time to draw the table, right? And put my workings for part 1. So when x is equal to, what's the value of x for the last column there? 5. So y, now I seen it again, because guys, I don't want nobody coming and saying that they're not understanding this, right? Or even if you don't understand it, still tell me and I'll really explain it, right? So you see this what I'm highlighting here, y is equal to 3 divided by x. This is what I am using for every single column to work out the value of y, right? So I'm going for the last column. Y will be equal to 3 divided by what, guys? 5, 0.6. Everybody good here? Make sure you have this table. Copy this table. So we found our values of y for which we were given x, right? I'm scrolling down now to see what the second part of the question is because I did complete my table, right? So let's go down. Now they said using a scale of 2 centimeters to represent 1 unit on the y-axis, sorry, the x-axis, and and hold on, yes, and 1 centimeter to represent 1 unit on the y-axis. Plot the points from your table, drawing a smooth curve through all these points, right? It's going to be a curve because they said it's going to be a curve, right? So this is gonna be the most important thing. Now, I did graphs with a different class last week, and they struggled, right? They struggled. So I want everybody to lock in, get your graph paper. Let's first examine how we going and set up this scale, right? So let me get my graph paper here. Graph page, copy. All right, come in here now, paste. Right, I got a picture of what most graph pages are, and that's what I'm using, right? Which is this, okay? Right, everybody seen my graph page? Right, so the first thing I'm gonna write above my graph is the scale, right? So I can write it, you can write it like in this top corner right here. So you just put x-axis, right? X-axis, pencil. X-axis, right? So your x-axis is going to be 2 centimeters to 1 unit, right? Okay, that's my x-axis. And then, wait, Sadie, you still here? Sadie, I don't think Sadie here, nah? Her mom said her screen was sticking. I'm gonna write a little neater. I find I didn't write it neat enough. X-axis dot ah Caitlin, you with me here? Sit on. Right, x-axis is a new. No, watch what they say for the y-axis. What they say for the y-axis is a new right, a new writing part I have here, but I'm struggling to write it, boy. Yeah, right. What they said for the y-axis? Anybody? You seen it in the question? 1 centimeter to 1 unit. Right? Okay, so we have our scale above there, right? Anything we could do, we could pull this around a little bit because it wasn't meant to go beyond what the graph is, right? Right. Everybody good here? Right. So, something you could examine is you could go to the table. Are there any negative numbers in this table? Right. Now, if you have negative numbers, you will have to draw your graph center and center. But because we don't have any negative numbers, we can actually draw this thing. Watch. Um, so I'm going to insert. So I'm insert a line, right? Right. So I'm going to draw my y-axis here. Right. You're drawing your y-axis here. I will make it a little broader. Huh? Oh, that's how I was zoom in. I was zoom in. Sure, no problem. Put an arrow on this side, label here x-axis. Then I want you all to label, here the origin, right? Here would be, I just put a dot so y'all can see clearly. Here would be the origin, which is 0, right? So put it as 0 for now, because it means 0 on the x-axis, 0 on the y-axis, right? Okay, 0 is this point here. Here is 0. And then I want you all to label up here y. Y-axis. Right? We are real struggling with this new writing part, boy. It's so sensitive. All right. So you have the x-axis, you have the y-axis, right? Everybody with me so far? I want to know that you all have this. Right. So some of the most important things that must be on a graph is you must have your axes on the top here. Then you must have hey Sadie, I now see your mom trying to call me there. What you could do, leave and come back. Hi, hi. I couldn't answer, but I told her to leave and come back and try it again. Cause it's none of the other children experiencing that, so there'll be something on her end. Anybody else whiteboard? You're not seeing the whiteboard or the whiteboard? Anybody else experiencing that? No. Okay, so something on her end, a student getting problems. All right. Okay, so let's go. So you must have your axis, your scale for your axis, right? You must have your label for your x-axis and your label for your y-axis, right? You must also have your heading for each axis, right? So let's see what the x-axis represents. I think the x-axis was seconds. Was it seconds, guys? Is it seconds? The x-axis. You see your x-axis values were seconds. They said where y represents the velocity of a particle after x seconds. So you must write the word seconds underneath here. So put that in for me, please. Seconds. Don't write it too close to here, because we're going to put numbers above here, right? Seconds, and here was velocity, which is actually speed, but we just need to put the actual measure, which I believe is meters per second. Let me just confirm that. Right. Meters slash s would be meters per second, right? So you can just put meters per second here for this axis, right? Meters per second. Sadie, are you on a phone or are you on a laptop? What you could do, if you're not getting shown on your laptop, try your phone. That might be the best thing to do. Right. So everybody good here? So let me analyze this thing here, right? So they said x-axis is 2 centimeters to 1 unit. Now, everybody's lining on their graph might be different, right? Some people might actually not have this 1 centimeter bolded line here. It might just be bolded every 2 centimeters. How many people's graph is not looking like mine's? Meaning these linings here. How many graphs are not looking like mine's? So Dominic, just send me a picture of yours now. Let me see how yours looking. Like different, real different. So I'm going to say it again. You can take your ruler and gauge it if you're not sure how much 2 centimeters would be, right? So let's go. We're going to label 2 centimeters to 1 unit. Oh, good. Empress. You see this? Empress. Get a new graph book for me, please. You hear me, Empress? Yeah, that graph book can't work. It cannot work. Right. I seen the graph pages here, right? So let's go, right? So 2 centimeters to 1 unit. So this is how it goes. So where you measure 2 centimeters to be, you can take a ruler and measure it. For those who are not sure, that is where you put 1 unit, meaning one, right? 1 unit. 2 centimeters to 1 unit. Aaron, you getting that? Kimani, you getting that? 2 centimeters to 1 unit, right? Makes, yeah, that's part a little dash to represent what it would be. You could put that if you want, right? And then you count 2 centimeters again, and it'll be another unit. So you go up by one. So that'll be two. So you have 1, 2. So every 2 centimeters you go up. So 2 centimeters again, we put 3, 2 centimeters, 4, 2 centimeters, 5, 2 centimeters, 6, 2 centimeters, 7, 2 centimeters. I'll go up to 8 here. All right. So make sure you have this because I'm going to say it again. 10 of these smaller boxes on the inside here will be 2 centimeters. And press your hand still up. Mistake? Right. So that is my x-axis. Everybody good here? Right. Let me go. What is the scale for the y-axis? It's 2 centimeters to 1 unit. It's a totally different scale. I don't like how this close here. 2 centimeters to 1 unit. All right. So we scrolling now. We're going to deal with our y-axis, not 2 centimeters, sorry, 1 centimeter to 1 unit. So this is how your y-axis is going to be. It's going to be a totally different labeling, right? So let me go. We go in, right. This will be 1. This will be 2. This will be 3. Every 1 centimeter, you put in 1 unit. This will be 4. This will be 5. This will be 6. This will be 7. It goes straight up to 23. Now, to avoid wasting time, right? Since you're on your y-axis, you can actually go to your y-axis column and see what the greatest number is here. The greatest number is 12. So you can probably just go one unit over 12. So we can probably just go up to 13 to avoid not wasting too much time, right? So we go in here, 7, 8, 9, 10, 11. I missed that one there, but that's okay. Yo, let's make sure you have the right thing. 11, 12. Right, I went up to 13. Okay? Up to 13. So, everybody looking here? Looking good here? Everybody have this? Two different scales. On your x-axis, you have 2 centimeters to 1 unit. On your y-axis, you have 1 centimeter to 1 unit. This is what trainers catch a tail to understand, the scale, right? So if you understand it, give yourself a pat on the back, right? 2 centimeters to 1 unit on the x-axis. Very good, Ruja. Very good, Amelia, right? 2 centimeters to 1 unit on the x-axis. 1 centimeter to 1 unit on the y-axis. That's scale in a nutshell, right? Once you can understand that, you understand scale. Tyler, talk to me. You good there? No, that graph book is sorry for the lack of a better word, is a stupid graph book that people were buying, right? Because that numbers on it. Scratch all them numbers. You don't follow that. You follow what I have, right? Superimpose your numbers. It went up to 210. I know what you're talking about. I know the graph book. Yeah, I know the graph book is real failure. Look, Frederick. Frederick sent me, she sent me a picture here and it's the same kind of graph book she have. So Frederick, very good. Frederick, that's right over it. And now we do Frederick from what I seen here. Yeah, the one going up the road. Very good. Right, very good. Right? Yeah, don't study what the book have, eh? That will get all in trouble. Right, let me go. So we going up to our table. Now our table is what give us our coordinates, right? Our table is what is going to give us our coordinates, right? So lucky, né? I'll scroll it down and you're going to give me the coordinates and I'll write the coordinates on the side here, right? So my first coordinate from my table, right? What is the x value of the first column? Anybody? That's wrong. The first column, 0.25, right? Comma, what's the y value? 12. So when you are writing a coordinate here, I've seen it, these things over and over again. When you are writing a coordinate, your x-axis value is always first and your y-axis value is always second. Seen it again. When you are writing out a coordinate, your x-axis value is always first and your y-axis value is second, right? So let's go. Second coordinate from the table. What's the second coordinate? Comma. Now when I say coordinate, I'm talking about the two values. What's my third coordinate? You know what I do? That's all. I'm gonna call on people. I'm gonna call on people because I want to make sure people following me here. Right? Janaya, what's my third coordinate? Right. That's it? Yeah? Zanaya, what's my fourth coordinate here? Aaron, what's my next coordinate here? 3 and 1. Right? Next coordinate here, Sarah. Melisha. What's my last coordinate? Think it's the last one, I'm not sure. What's the next coordinate, Melisha? 5 and 0.6. Did I have a next one, Olive? What's the last one? So, yeah, you could copy it. Write it as a coordinate, right? So, Caitlin, I remember when you did send me your end of term exam, you had a lot of questions like this. You see how easy this is, Caitlin? I know you wasn't able to understand it when you were taught it in school, but do you understand it now, Caitlin? What do you think I'm going to do with these coordinates, Caitlin? You just have to plot them. We just going to plot them on the Cartesian plane. Because I see again, you must get 3 or 4 questions like this, eh? I see a hole in your head. So I'm sorry you didn't get to do it before your test, girl. Yeah, the coursework, all right, but I see that you get a lot. Right, so let me go. Um, we're gonna plot these points. So all you have to lock in, eh? Lock in. We go to the first coordinate. Now the first coordinate is 0.5 comma 12, right? 0.5 as zoom in straight in, right? 0.5 is actually going to be a quarter. Sorry, 0.25. 0.25, thank you very much, Dominic. 0.25 is going to be a quarter. So look at some things, right? This stroke here is going to be what? Who can tell me what this stroke is going to be here in the middle there? Excellent. 0.5. Right. It's in between. Lord. Right. 0.5 is here, right? So 0.25 is going to be between 0 and 5, right? So points to note, they actually counted in point ones. So here would be 0.1, 0.2, 0.3, 0.4, then 0.5. 0.25 is going to be between 0.2 and 0.3, right? Which is going to be here. It's going to be between the two small lines. This is 0.25. So see if I can locate that 0.25 for me there, right? Now you all don't have the ability to zoom on your graph paper in front of you, but you could make it out. You could make it out. Right? Let me write this a little bit. Right, I put it in the middle here, right? So 0.25, right? I'll write it kind of bent. God, do have the spacer there, right? 0.25. So we going, where's 0.25? We going up and 12 meet. Where 0.25 and 12 meet is where my coordinate is going to be. So I'm following the line of 0.25, but yet you could see it from up here, right? You could count it from here. Look how you're going to do this, eh? You could come by 12 and you're counting, this will be 0.1, this will be 0.2, this will be 0.3. So, in between here is going to be 0.25. Right? Everybody see that? Yeah, I got zoom in. Zoom out or zoom in? Out. You want to see the whole thing? This is the zoom. This is the zoom out, right? Right? So, this is my coordinate here. It's in between the, I'm going to put our X. It's in between the line, eh? I'm going to put our X instead of our point. You can put our X there, guys. Right. Wait, I'm going by 11. Wrong number. It's by 12 and 0.25. So I'm going to put our X here. Right? This is where the point is. X marks the spot. So who is not getting this? Come on, ask the questions. 3, 1. 3 on what axis, my children? 3 on the x-axis. And 1 on the y. So that coordinate is here. Right? We're looking real good right now. When I start to plot graphs, so all are going to be moving at real speed. Wait, what's that, boy? I just wanted to fix this. Let's dot something. Right, give me the other coordinate now, please. 4 and 0.75. Now, in the middle here will be 0.5. This will be 0.6. This will be 0.8 because you're moving in 2, so this one, right? So 0.75 will actually be in between here. In between 0.6 and 0.8, but it will be closer to 0.8. Right? So watch it here. This will be 0. This thing doing this way. Hold on now. Right. Follow this there, guys. I want to zoom in some more. Right. Watch it there. Each small box here would be 0.2, 0.4, 0.6, 0.8, and then 1. So you actually going up in by 0.2 for these small boxes. On the x-axis, you're moving by 0.1. Is everybody clear on that? Right. What's the next coordinate? Next coordinate. Right, so 0.6 is going to be 0.2, 0.4, 0.6 is on this line itself. Right, everybody got there? 5 and 0.6. Hey, if anybody not getting through, Aaron, me and see you right, no? You getting through? What you doing? Send your graph for me, dog. Send your graph for me. Send a picture. Send me a picture how your graph looking. Just check the graph. I mean, check the table, sorry. Check the table, bro. Yeah, that'll be the internet CD. Sorry about that, but I record in the class, so we'll see what's going on, right? Hey, somebody give me the next coordinate, please. 6 and what? 6 and 0.6 again? That's all. That's confusing me. We on 6. 6 and what? Right, so 0.5 will be in between 0.4 and 0.6. So that's it. Right? Let's draw this a little better. Right, 7 and what? Right, so all you're going to draw a smooth flowing curve through these values now. So I actually have a curve that I could draw, but try to see how smooth you all can get. So you come down here, you're not using a ruler. If you use a ruler to connect any one of these points, you'll get the question wrong. It's a curve, right? So you're coming down here, right? That's 1. Then you come in here, 2. Then you come in here, 3. Right? I'll make the curve a little bolder, 4. And then you're swinging 5, 6, 7. Right? Let me make it a little more bold. Hold on. Right. Everybody see my curve there? And I'm going to label my graph as the function that we were given initially, right? So I'm labeling it in red so you can see it clearly, right? So the function is y is equal to 3 over x. That is the function we just drew. Give yourself a round of applause if you get this out. Right? I see people sending me pictures. Moving on. The table below gives the number of cars sold in a country in hundreds from 2010 to 2014. 2010 to 2014. So the number of cars sold in hundreds, right, would be 1900, well, 1000, 2600, 1600, and 3000, right? That's basically what it is. But it has given, they just told you it's cars sold in hundreds and they give it as 19, 10, 26, 16 go down the road, right? We go into the graph now. Let me see what's going on with this graph here. Let me see if I can make it bigger. Right. Right. So on my graph, on the x-axis, I have the year. So who can tell me what's the scale here? How much years, how much centimeters to 1 year? Anybody? Who could tell me what's the scale here for the x-axis? 2 centimeters to 1 year for x, right? And how much centimeters to how much units on the y-axis? 2 centimeters to how much units? 2 centimeters to how much units on the y-axis? That's the scale. Asking you, 2 centimeters here represents how much units? Look, I see Ariana put it up and somebody said 5, right? So the scale here, they did not write the scale, but the scale for the y-axis would have been, I'm going to put it in, right? So there we go. I think I've got my ready. Hold on. Look at my blowing. Right. So the x-axis would have been 2 centimeters to 1 year, right? And the y-axis, let me make some space in between here, right? Fighting up to write this in this small space here. Right? 2 centimeters to 1 year for the x-axis, right? This is the x-axis. And your y-axis would have been I'm not one, sorry, 2 centimeters to 5 units. All right. Okay. Two, five, what? Yeah, yeah, you can see 500. Up here, I didn't multiple 1 year, no. I know I would have chosen for that 1 year, no. I can just put 1 unit because it's just going up by one. It went from 2011 to 2012, so you can actually just put 1 unit here, right? So let me put that so I would not show you all off, eh? Right? Five, we counted. No problem. So units, right? Let me just use the words units, right? Ariana, you good there? So we go in. So 2010 to, how much are we counting here? What does each small box represent on this y-axis here? Who could tell me? If from here to here is 5, how many boxes represent 1? This is how we analyze this graph. Eh? Go ahead, Aiden. 5 boxes. Right. So watch what Ole is saying. 5 small boxes represented 1. This is where we had to think. 5 small boxes represent 1. That's what they're telling me, right? So this will be 1, and then this will be 5. So this will be what? This will be 6, and this will be 10. So you see where the logic that's coming? How many small boxes represent 1? Come on, I need all to think. Excellent, Ariana. Right? 2 small boxes. How did I get that? If from here to here is 5, right? And that's actually 10 boxes. I could say 5 into 10 is 2. And you'll know every 2 boxes would represent 1. So this will be 1. Then you count 2 small boxes. This will be 2. Then you count 2 small boxes. This will be 3. 2 small boxes. This will be 4. And then 2 small boxes, 5. Everybody with me there? Come on, tell me if you're with me. Tell me if you're with me. Kimani. Right. Wait, we had a draw there, but let me do it. Let me do it first and then I'll draw it, right? Actually, I could leave a little draw this. Draw it first. Yeah, you'll draw it. Draw it. Draw it quickly. Right? Now I'm gonna pause the recording. Now this is a line graph. So it means that you're taking your ruler and drawing these lines. Right, Dominic? You heard me? It's a line graph. Okay? So please use your ruler. If they say curve, then you know you're not using no ruler. You could use your yeah. Right. So let me plot them. Let me plot them. 2013 and 16, right? So as Joshua was saying, there's 2 boxes, right? Let's make sure. Okay, all right. 2 boxes after 15 would be 16. So I go to 2013 and I go up to 15 and then 16 would be 2 boxes. So it'll be here. Right? Everybody good there? Right? So I drawn a straight line from 2012 to this box. And then 2014 was what? Somebody tell me the number for 2014 now. 3030. So I'm going straight up here. Alright, so I'm going straight up to 30. That will be here. Simple line graph. This is the easiest question I ever do for graphs. Alright, so let me join them up, right? I need to insert a line. Right, boom, bang. This one? The the blue dot. Oh, you mean on your paper? Yeah, that's hurt my eyes too, no, but bro, we gotta find our way, yes? Right, bro? I need wheat of this thing to be a little thicker. So I'm put the wheat a little thicker. Right. 2012 to 2014. They said between which consecutive years, meaning 1 year after the next. So it can't be 2012 to 2014. So there are only 2 pairs of consecutive years that there's an increase here. The question asks between which 2 consecutive years, meaning if it's 2010 to 2011, that's consecutive years, was there the greatest increase in cars sold? Now, judging from the graph itself, how many increases we had? Who could tell me that? Looking at the graph, how many increases in sales we had? 2. Look, I say Ramjan, belt it out, belt it out. Don't afraid to belt it out. Ramjan had it up, right? 2. 2 increases. It had an increase from what year to what year? What's the first increase? 2011 to 2012. And then, go ahead, Ramjan. 2 increases we have. So visually, that's looking at it, right? We are working out nothing. You're looking at it. Which increase looks greater? Simple as that. The greater increase or the increase where the line looks longer, you could say, is 2011, sorry, to 2012. That's the 2 consecutive years they're talking about. So this answer here would simply be 2011 to 2012, right? So you have 2011 to 2012, right? Isaiah, your mic on. Yeah, unpause it. Thank you. Right, let me go. What was the total number of cars sold for the 5-year period from 2010 to 2014? This is an addition question, right? What's the total number of cars? Now, if they access the total number of cars, we given them it, they did not say, well, actually, the question above is those numbers are in hundreds, right? So if you want the total number of cars, you have to give them their answers in hundreds, right? So let me add the numbers. What somebody give me out? I don't want to scroll back up. Somebody give me that. Give me 10 hundreds one time. Was it first year? 1900 plus 1000 plus 2600 plus 1600. Right. And what did we get our answer to be here? Somebody second 8,500. Right. Yeah. All right. Remember they said this is cars sold in hundreds. So 100 means that you're adding 2 zeros if you want to put it like that. So this 19 is actually 1900. This is actually 1,000. This is actually 2600. This is actually 1600. This is actually 3000. Right? Oh, I didn't get the time to write it. Anybody need to write the table? Yeah, right. Write it down quick. 10,100. 10,100. Those who got 8,500, check it over. Right. So mean are doing it in normal numbers, right? Not the hundreds, are not attaching the hundreds, right? So basically, what is the value for the first year? Give me the values again. Oh, look them right above here. It will be 19 plus 10 plus 26 plus 16 plus 30 plus some value x because it's up to 2015, right? There's an additional year. Divided by how many years do we have in all, guys? How many years do we have in all? Huh? 5 years. 1, 2, 3, 4, 5. It's up to 2015. It's an additional year. It'll be 6 years. 6 years. Look, they said the mean number of cars sold from 2010 to 2015. Does my table have 2015 here? You all see 2015 there? No. So 2010, 2010, 2011, 2012, 2013, 2014, 2015 is 6 years, right? So that's why I put an X here. X represents the additional year. We don't know the value for that year because it asks us how many cars were sold in 2015. That's what we're trying to find. This is a primary school question. I see my daughter doing questions like these, where you need to find the missing amount given the mean, right? So this is 22.5. So what you do here, you carry the 6 to the side and you do the opposite of divide, which is to multiply. Okay? So what I want somebody to do, add up all these numbers to me. What did we get? That would be the same. All right. It'll be 101. 101, right? 101 plus x is equal to 22.5 multiplied by 6, right? Okay? 22.5 multiplied by 6. Right. How much you get? Coming down here, right? I could write it there. Right, so 101 plus x is equal to 135. What do I do with the 100 when I carry it here? This is algebra. Right, take away. So x is equal to 135 minus 101. X will be equal to 34. So the missing value is actually $3,400. But it didn't access 1,500, so you can leave it at 34, right? No, no, no. How many cars are sold? So let's put the 3,500 there. So I'll just put underneath here. Because when you access how many cars sold, it wasn't 34 cars, it was 3,400 cars. That's the catch in this question, you know. So therefore, 35, not 35, I get 35 from 3,400 cars were sold. 3,400 cars were sold in 2015, right? This is a primary school question, eh? They do this in primary school, right? Question done. All right, so we're gonna draw our x and y axes. All right, let me label them. I need some space. All right, so this will be my y axis scale. X axis. So what's the scale there for the x axis? Anybody? I think it's 2 centimeters to what? 5 years. And y axis is what? To 1 million. Yeah, to 1 million, to 1 milli. 1 milli. 1 milli. All right. So there we go. We have our 0 here, right? That's the only thing we show about the short as 0 here, right? Did you put your x axis here? X axis, right? Some scratches there. Right. Make sure and label your axes. So here, the x-axis will be years, and the y-axis is what? People? Was it people? Population. Yeah, that's the population in millions. Population. Population in millions. All right. Find this could come around a little bit. That's all. All right, let's try to fit it in because it is necessary. It is necessary, right? Right, so there we go. I'm going to belt out my years here, right? What year is it to start with? 1985? 1980. Thank you. I actually knew it was 1980. I just want to see who here with me. So we counted in five. So this will be 1985. How much you going up to? We are space all that here, right? 1995, 2000. How much you going up to 2005? Right, that's all I put in, right? And 4 centimeters, right? You're counting 4 centimeters, which is boom, 1 million. 4 centimeters again. 1, 2, 3, 4. 2. We need to go up to anything else? No, I don't see anybody more than 2. It's only 1 point this, 1 point that. And then 2 is the highest one, but I'll still put 3. I'll still write in 3. And 3, 1, 2, 3, 4. Right, let's put 3 for formality. Right, let me work. So 1980 is the x-axis value, comma, what is the y-axis value, my children? 1 point what? 1.10? 1.10, thank you. 10 is 10. It will be 10 point something. 10 is not a decimal. Right. So there we go. So 1.10. So we need to figure out how we count in here. How much small boxes we have between 1 and 2? Anybody? How much small boxes we have? It is 4 boxes. Right? Every 4 boxes is what? Right. But how much boxes would be 0.1? That's what I'm asking. The smaller boxes. How many small boxes would be 0.1? How many small boxes, and not 1 centimeter boxes, right? How many small boxes we have between 1 and 2? Anybody? How many smaller boxes we have between 1 and 2? Did anybody count it? Somebody say it. I've seen it on some people's mouth. 20, thank you. Well, they're making this thing look hard, boy. From here to here is 5 boxes. 5 and 5 is 10, 15, 20, right? Somebody's saying something, but that person might real give in trouble, boy. I'm not hearing you at all, you know, whoever it is. Message me now, message me. I'm not hearing you. No, something, again, some feedback there from your mic. Right? So there we go. It is 20 spaces, and if it's we go up in point ones, it's actually 10.1s, you could see. Right? Yeah, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, well, not 0.10. After 1.9, it will be 2. So you do 20 divided by 10, which will give you 2. Every 2 small boxes would be 0.1. So this will be 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. Everybody good there? Talk to me earlier. I ain't here no boy. Right. Every 2 small boxes is 0.1. So this will be, I'm writing it out there, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and then 2, right? So the first one was 1980. What is the y-axis value? The population will represent the y-axis value, right? X-axis value on top here, y-axis value underneath here. My y-axis value is 1.1, right? So I am drawing this x or point or whatever you want to use, right? You can use an x or you can use a point, right? This is going to come at 1.1. It should be here. Raise hand if you got this. PowerPoint, I'm on PowerPoint, right? One, huh? Okay, right. Let me go. 1985, comma what? 1.24, right? So watch it. 1.2 is here, 1.3 is here. So 1.25 is in between that. So 1.24, that's be a little under 1.25, right? So that point will be like right underneath here. Right? Here we're putting dots to this one, eh? Putting dots. So we had 1.1, right? Right. 1990, comma what? 1.35. We hunting for 1.35. 1.35 would be between 1.4 and 1.3, right? 1.3, 1.4, and 1.35 is in the middle here. Yeah? Yeah, go ahead. 1995, what is the y-axis value? 1.86. So we make a jump here. 1.8, 1.76. That'll be right above 1.75, right? It should be like right here. Right? Right there. 2000 to what? 1.82 would be right above 1.8. Somewhere right there. And then I know 2005 was 2. Is this a line graph? Yes, it is. All right. Draw a line graph. So rulers out and we connecting. So let me go. I ain't getting into thing, man. Yeah, no problem, Ali. Right. This is a line graph, eh? So using rulers. Ruler. Leo, go and organize yourself, please. Yeah, go ahead. Yeah. What you want to see? What you want to see? Up here, the table. Which one you want to see? I say, but it's sending me the line graph here. Now, if you don't use rulers here, you're off, you're wrong. Jana St. John, draw a line from 1980 to 1985 because that line you draw there, you're looking like you missed 1985. Right, Jana St. John? Let's look at the question that CXC is asking us, right? Okay, scrolling back down. They said using on your graph, show how to estimate the population of the country in 1998. Write your estimated value, right? So once again, I said we have to locate 1998. Every two small boxes here will be 1 year. So this is 1995, 1996, 97, 98, 99, and then 2000, right? So 1998 is here. I'm going to write it in, right? 1998 is this one here. Let's erase the others so that you all would not get confused, right? Move this, move this, move this, right? That is 1998. So we're going to draw a line going straight up to the graph, and then we're going to link it. In other words, we're going to link it to the y-axis and see what number it lines up with, right? So let me get a line here. Insert a line. I'm going to make the line red so y'all can see it, right? So we coming from here, we going up to the graph. Boom. Right? I'm going to make that line red. Wait, what's that? I got that red and red now. Right. And then I'm going to draw a line going across to the y-axis. And then I'm going to see what it lines up with, right? So hold on. I draw this line going across here. What y'all getting? I am getting between 1.8 and 1.9, which will be 1.85. Tell me if you're getting 1.85 there. Right? So let me go out a little bit so everybody can see it. Gonna scroll in. Is it lower? You need to follow Amelia. This is 1998. I draw it up to the graph. Right? This whole thing is. Right. Right. So I draw it up to the graph. I meet the graph. 1998 is in line with this red line, right? So I drew it up to the graph. I stopped at the graph. You could establish a point, and then from this point now, you go across to the y-axis to see what amount the population would be for 1998. And I'm getting 1.85 because it's in between 1.9 and 1.8. So the population amount I'm getting is 1.85 million. Okay, guys? 1.85 million. Right? Going back to the question, during which 5-year period was there the greatest increase in the population? I could look at my graph and see that from 1990 to 1995, there was the greatest increase, right? It went up the most. So I'm going to write that down there, 1990 to 1995, right? Let's make a space here. Right? So 1990 to 1995. Now, the smallest increase I feel you might have to work out this one. Because look, all these lines looking the same. You all fine? Right? So with this now, we could go to our table. For me, the smallest increase looking like 1985 to 1990. A little fine. Very good, Aaron. So 0.6, right? So that, what year that was by? That was 1995 to 2000. 1995 to 2000 had the smallest increase, right? So y'all, this is not easy graph questions. These are tough graph questions. So if you're getting out this, you're doing excellent right now, right? So right, 1995 to 2000. What the next part of the question asks? Or question done? Question done by... Right, so it's 6:56. So I tell you straight off the bat, we're doing all these questions here for homework, right? Which we will correct in next class. But we start in speed time graph. It have a pie chart here too. I am giving you all this homework also, right? Go and try to see if you can figure it out. We would do it in the next class, right? And from here, speed time graphs, which will be starting next day. Okay, guys? So, sorry we couldn't make class on Tuesday, but next week we go back to Tuesday, right, guys? Okay? Y'all enjoy the rest of your week, and yeah?